You picture this, a young scientist. It's 2012. And she's looking through a microscope. And she's seeing something that, well, honestly, it just shouldn't exist. Not by the book, anyway. It was a bacterial immune system, sure, but one that held this incredible key. It could be programmed really precisely to cut any DNA sequence, like tiny molecular scissors. That scientist was Jennifer Doudna, the discovery, CRISPR-Cas9. And that whole story, the science, the huge aftershocks, that's our deep dive today. We're getting into Walter Isaacson's fantastic book, The Codebreaker. We want to unpack the science, yeah, but also the ethics, the really human drama behind this whole gene editing revolution.
Yeah, and what Isaacson does so well, I think, is he doesn't just give you the science biography. He frames it as this. Well, it's like a thriller about ideas, right? And a courtroom drama over the patents, and definitely a deep philosophical question. So our goal for you today is really to pull out the key insights, not just what CRISPR is, but fundamentally why it matters so much to all of us, especially now as we're sort of standing on the edge of being able to rewrite life itself. Okay, let's get into it.
Right. Let's start at the beginning then. Following Jennifer Doudna's journey, just like the Codebreaker lays it out. From her reading The Double Helix as a kid in rural Hawaii, who's kind of planted a seed, all the way to standing on the Nobel stage. It's quite an arc, curiosity, hard work, and maybe a bit of luck, too.
Definitely. And what's really striking about CRISPR-Cas9, and the book explains this so clearly, is where it came from. I mean, bacteria. It started out as this basic immune system for bacteria, a way they fight off viruses. These bacteria, they develop these things called CRISPR spacers. They're basically like little genetic memory cards. They store bits of DNA from viruses that attacked them before. So next time that virus shows up, they recognize it and chop, chop, destroy it. The real genius part, the big insight, was realizing, wait a second. This natural defense system, which uses a guide RNA to find the target and this enzyme, Cas9, to do the cutting, we could actually program that. We could repurpose it as a super precise gene editing tool. Way better, way more flexible than anything we had before.
And Isaacson is just brilliant at making that complex science feel, well, understandable. He uses these really vivid analogies, like the guide RNA being a kind of molecular GPS, finding the exact spot on the DNA, and the Cas9 enzyme. That's like the track changes feature in your word processor, letting you cut, maybe delete, maybe even paste in new genetic code. And you get these little details, too, like the smell of the bacterial cultures, or that exact moment Doudna saw her first successful cut. She said the DNA gel glowed under the UV light like a child's nightlight, which sounds beautiful, right? Yeah. But also, as the book kind of hints, maybe a little ominous, too, given the power.
And that success, that glowing gel, it immediately raises this huge question, doesn't it? What happens when a tool this powerful, this precise, gets out of the research lab? When you connect that to the bigger picture, this discovery wasn't just about scientific papers for Doudna and Emmanuel Charpentier. No, it instantly kicked off this incredibly intense global race, a real sprint. Not just for understanding, but for the patents, the money, the sheer power to change biology. And that, as we'll see, pretty quickly set us up for some major ethical hurdles.
Yeah, this is where the story in the book really picks up speed, doesn't it? It goes from science discovery to this high-stakes thriller.
Right.
Once everyone grasped what CRISPR could do, suddenly it wasn't just about curiosity. It became this massive international sprint, like you said. Who could publish first? Who gets the patents? Who commercializes this game changer? Isaacson really builds the tension. Like you're reading a detective story, digging through clues, emails, lab notes. It keeps you hooked.
Yeah. Oh, absolutely. That section reads like proper forensic accounting. He meticulously details the huge patent fight between UC Berkeley, that's Doudna and Charpentier's side, and the Broad Institute, mainly Feng Zhang over there. He's looking at email timestamps, digging through lab notebooks, talking about late-night calls, all trying to pin down who really first showed CRISPR working in human-like cells, eukaryotic cells. And the stakes were just massive, not just bragging rights, but potentially billions of dollars from therapies down the line. It wasn't just a scientific argument. It was all-out legal and business warfare. Shows you how fast big science gets tangled up in IP fights.
It feels almost like something out of Shakespeare, People who work together suddenly becoming rivals, friendships getting strained, lawyers making a fortune while the scientists are stressing over who did what when. And the book really captures that drama around the Nobel Prize announcement in 2020. For Doudna and Charpentier. Isaacson paints it as, a huge win for them, finally recognizing their core discovery, but also kind of bittersweet for some, because it really highlighted just how fierce the competition had become, maybe overshadowing that collaborative spirit science is supposed to be about.
And if you think about that competition, that race in the bigger picture,
right,
It's a double-edged sword, isn't it? On one hand, sure, it pushed the science forward incredibly fast. Innovation was happening at lightning speed. But on the other hand, and maybe this was unavoidable, it meant the technology sprinted way ahead of our ability as a society to figure out the ethics. Everyone was so focused on winning the race, getting the patents, that the really deep conversations about, the huge responsibility of rewriting life, well, those often felt like they were lagging behind trying to catch up.
Which brings us right to that core tension in the Codebreaker, doesn't it? This clash between the incredible speed of the science and the much slower, often really messy process of developing ethical wisdom. It's a theme that just runs right through the book, making you ask some pretty tough questions about progress and responsibility.
And nothing highlights that clash more brutally than the announcement in 2018 from He Jiankui in China. The CRISPR-edited twins. The global reaction was, quite rightly, horror and condemnation. I mean, these were germline edits, changes made to embryos that would be inherited by all future generations. And this was done without any real ethical agreement, without proven safety. As Isaacson shows, the scientific world was still just starting to debate the ethics of human germline editing, and boom, it had already happened. The patents were out there, the venture capital was flowing. In a way, the genie was already out, the immediate moral fallout was huge, but the tech itself just kept moving.
Isaacson does this amazing thing he calls a moral kaleidoscope. He just presents all these different viewpoints, often clashing. You hear from bioethicists, right, warning about genetic classism, like, will only the rich be able to afford these enhancements? Then you hear from disability advocates worried that editing out conditions might lead down a dangerous path, maybe towards a new kind of eugenics, devaluing human difference. But then you also get these really powerful, heartbreaking stories from parents. Parents who do absolutely anything to save their child from a terrible genetic disease, like Huntington's or cystic fibrosis. It's so complex, it really forces you, the listener, to think, okay, where do I stand on this? What would I do?
And Isaacson himself, his own view in the book, it clearly evolved. You see him grappling with it. He starts out maybe more purely championing the innovation, the excitement of it all. But later, you hear these stronger warnings about hubris, about needing caution. By the end, he's actually arguing for a global pause, a moratorium on making heritable edits, those permanent changes passed down through generations, at least until we can get some kind of global agreement on how to govern this. Which, feels morally right, but maybe realistically very hard to achieve given how different countries are. It really makes you ask, can a scientific tool this powerful ever be truly neutral? Or does its very existence force us to confront these moral questions immediately?
Wow. And just when you think the story can't possibly get more intense, the Codebreaker takes this completely unexpected turn right at the end. Because suddenly CRISPR, this tool from bacteria, gets thrown onto the front lines of a completely different battle. The COVID-19 pandemic. It's amazing how versatile it turned out to be.
Right. And that immediately raised a new question. Okay, can we pivot this incredibly powerful gene tech to fight an immediate global health crisis? And the answer, kind of astonishingly, was yes. CRISPR was adapted incredibly quickly to make new kinds of rapid diagnostic tests. Things like Sherlock and Detector became really important for testing, for tracking the virus. They used CRISPR's precision to find the viral RNA super fast. It also helped speed up vaccine research. And there were even explorations into, well, more out there ideas, like using CRISPR to create a kind of molecular seek and destroy mission against the coronavirus genome itself. The scientific community's ability to just repurpose this complex tech so fast was frankly remarkable.
Yeah, Isaacson paints his picture of Doudna spending her birthday on Zoom calls, coordinating research across the globe, collaborations that maybe just a year before would have seemed impossible in terms of speed and openness. The pandemic really acted like this massive stress test for scientific cooperation, didn't it? It showed what's possible when scientists pull together against a common enemy. That urgency just pushed everything forward.
But what's so telling, and the book brings this out, is the contrast. If scientists can share data and protocols almost overnight to fight a virus, why is it so much harder to get global agreement on ethical rules for gene editing or to address worries about genetic inequality? The book suggests the answer isn't really about the science being too hard. It's more about, well, politics.
Yeah.
And profit motives, and maybe just that human tendency we have to compete, to commercialize things fiercely, maybe sometimes instead of focusing purely on the collective good and the long view.
And then maybe the part of the book that hits hardest, that feels most personal, is what Isaacson calls his metafictional twist. He actually puts himself right into the story. He gets his own DNA sequenced and finds out he has a genetic variant that significantly bumps up his risk for Alzheimer's. Suddenly, this isn't abstract science anymore. It's incredibly personal for him.
Exactly. And what makes it so powerful is what he does next. He doesn't just keep it to himself. He sits down with his own adult daughters and asks them this incredibly difficult hypothetical question, but it doesn't feel so hypothetical anymore. He asks, if they could have gone back, if they could have edited the embryo that became him, knowing about this Alzheimer's risk, would they have done it? Wow. I mean, that takes it from science fiction right into the middle of a family conversation. It becomes this really intense personal dilemma about choice, about genetics, about identity, all playing out between a father and his daughters. It really puts you, the listener, right there in that uncomfortable but increasingly real conversation.
Yeah, that scene is short, but it's just incredibly potent because it snaps the whole thing from theory into real human stakes. It's this stark reminder that this revolution, it isn't just theoretical science, it's heritable. It could affect you, your kids, your grandkids, generations down the line, the ripple effects through families, through society. We're only just starting to even think about them. That really stays with you after you finish reading. So quite a journey we've taken. From a basic defense system in bacteria, all the way to a tool that genuinely gives us the power to reshape humanity. And the code breaker, well, it doesn't really tie things up neatly, does it? It leaves us with this huge hanging question mark. What are we collectively going to do with this absolutely unprecedented power to rewrite evolution itself?
And connecting that to the bigger picture, Isaacson sort of offers up what he calls a typically American answer, Innovation, yes, but balanced by regulation. Ambition, sure, but tempered by ethics. Genius, great, but checked by democratic discussion. But, and the book is very clear on this, whether that kind of answer is actually enough, whether it can really guide us, that won't be decided in books. It'll be decided by votes, by decisions made in company boardrooms, by scientific committees, and ultimately, yeah, by the very personal choices made by parents, maybe holding babies edited with CRISPR, babies who haven't even been conceived yet.
The final chapter, like the book says, it's being written right now, in real time, one base pair at a time. By all of us, really. So as you think about everything we've covered in this deep dive, here's maybe a final thought to chew on. How do we, as this complex global society, actually make sure that our wisdom, our ethical thinking, can somehow catch up to the absolute dizzying speed of our own discoveries? It's a question that just keeps evolving, doesn't it? Just like the code of life itself.